then it divides it. Now, what's the amplitude going to do? Well, the amplitude's going to get the RMS, right? That's what an amplitude does. In fact, it says it gives us an RMS signal. So what's it going to do to it? It's going to square it. It's going to take the average, and it's going to take the square root of it. Now, what's that going to do? What is the resultant number? The resultant number is always positive. Right? Can't have a negative amplitude because the first thing you did was square it. Right? So regardless of what I do, these numbers here are going to be positive. And when I divide a positive number by a positive number, it's going to be positive. And tangent from 0 to infinity, a positive number from 0 to infinity is going to put it in 0 to 90 degrees. All right, that's the tangent. If it's vertical, it's infinity. If it's positive infinity, if it's 0, it's 0, right? It's at the horizontal. So I'm going to get first quadrant angles out of it no matter what. So while it's certainly working here, and I'm getting nice first quadrant angles, I've mathematically restricted myself to only getting first quadrant angles. Grumble. Bummer. So, what am I going to have to do? I'm going to have to get some of the other angles. So, what do I need to do? Well, I need to not get rid of this sign thing. Somehow I've got to keep a positive and negative, right? I mean, I need this division here to be positive and negative, right? So that when it comes out of it, I'm not losing the sign in these. So, okay. Okay, how am I going to get them to be positive and negative? Well, if I square them, right, I get things that are all positive. So, okay, well, what happens if I multiply them by something that is potentially different, right? Like, okay, what we have here is I have 3 sine waves. I've got one sine wave that's the input signal, right? And then I have other sine waves. And let's say I have one of the sine waves, and they're going to pretty much, what happens if I have one sine wave that's doing this? It'll be at the same frequency because that's the way transformers work. It's at the same frequency. If I multiply these two together, what do I do? What do I get? I multiply the red one and the black one together, what do I get? Well, I get a positive value. Right? I get a positive value. It's twice as fast, right? Twice as fast. What happens if I have one that's doing this? What do I get when I multiply the blue one by the black one? Well, over here, what do I have? I have a positive times a negative. And so the result is going to be negative. And over here, I have a positive times a negative, and the result is going to be negative, right? And over here, so if I multiply it by something that doesn't change, right? Then what do I do is I can get that, I can keep the sign. Right, well, what doesn't change? Well, the input doesn't change. Right, the input's always the same, right? My input sine wave, it's at the same frequency, it's always the same. So what do I do if I multiply these by each other, right? So, ooh, okay, that might work. So rather than doing that might be, So does that make sense to somebody here, sort of in thinking about what we're doing? We're trying to get that negative sign out of it. So when we do this division here, we've got at least a chance of having the denominator be negative. And we've got a chance of having the numerator be negative too, right? That would be good, right? Wouldn't that be good?
Yes.
We're gonna think that's gonna be good? Okay, so now we need to multiply these together. Well, can I multiply these together?
Yes.
And the answer is,
Of course.
it's LabVIEW, of course you can. What do? We just go get some multiplies. And what I'm going to do is I'm going to first take the first channel, and I'm going to multiply it by the next one down. Now, do I want to take the RMS of this thing after I've multiplied it? Well, no, because it's going to get rid of that negative sign, and I worked hard to get that negative sign, right? So what do I need to do with these RMS things? I need to throw them away. Okay?
Hey, I haven't put the
You guys, stories would touch my heart. Okay? Well, what do I need to do to get, I still need an amplitude out of these. What do I need to do? Well, I've multiplied two sine waves together. They're either going to be a positive, they're either going to be in phase, in which case it's a positive times a positive, or they're going to be out of phase, in which case it's a positive times a negative. But in either case, I've gotten them to where they're not at zero anymore, right? They're not at zero. I've either squared them or I've squared them times a -1 kind of thing, even though they have different amplitudes. So now I can take the average of them, right? Because that's sort of we're doing the RMS thing, except we're doing it with different sine waves. They're at the same frequency, but we're doing the same thing, right? So now what do we need? We need a mean. And you guys know where to get means,
Yes,
right?
step.
Yes, you know where to get means. Some of you came in that way, but
I was gonna say from our instructor.
well, there was that too. You certainly can say that it contributed to the problem, right? Are you gonna? Is that a reasonable assertion there?
Yes.
Okay.
No.
So if I can do it once, I can do it twice. Right? And I can get another mean here, because I'm that kind of guy, as Taki reminded us so eloquently.
2.
Making my icons pretty, lining them up. You know, there's a whole bunch of tools in there for lining them up, making them pretty, that I'm sure you've all played with and made your diagrams, ladder diagrams beautiful.
Not played with all of them, but yes,
Whatever.
played with some of them.
Okay. I'm not feeling it again. Feeling some of it. Okay. So what are we doing here? We're taking the input signal and we're multiplying it by each of the sensor signals, which will actually help our amplitude because they'll get bigger than 1 now, right? That's going to be a good thing. They're going to get bigger than 1 because our input amplitude is bigger than 1. And then we're taking the average of them and we're outputting that to channel A and channel B and taking the part of the tangent out of that. Okay, so let's see how that works. We can run this. And ooh, yes! I get to celebrate and jump up and down and do all kinds of things because my angle is negative. That's right. So it wouldn't do that before, right? So 2, 1. Ooh, it goes back and forth. Right. Oh, there goes negative. Yes. Of course, I'm going the wrong direction, but 50, 60, 70, 80. Ooh, still only goes up to 89. Oh, and then it goes to minus 89.
Uh-oh.
Oh. So we're better, but
You gotta do it.
we've only got half a circle. Okay?
I can live with that.
No, you can't. Well, you can, but it will result in, reflect poorly on your performance here. So can I say that without getting you in, getting myself in trouble here? Right? I expect more of you. Okay, so, well, okay, so now what's the problem?
I need more multiplication.
If it's not, then I can.
Well,
You can just change it up.
what's the bounds on arctan? What's the limits on arctangent?
What is it? The.
Well, let's just look with the line. So you can't get any bigger than
Right.
positive infinity, and you can't get any smaller than negative infinity. Okay, right? So by definition, you're only going to get between plus and minus 90 degrees.
Yep.
Right? We can't get plus and minus 180 degrees because, and it makes a certain amount of sense, because what's killing us now is this division, right? Because what we really want is we want it to have, to know about the signs. Sometimes the numerator is positive, sometimes the numerator is negative. Sometimes the denominator is positive and sometimes the denominator is negative. We went to a lot of work to make them that way. Well, not a lot of work, but we put in a multiply and a average to get that number, right? Okay, that's why we did that, right? It gave us a positive and negative. But what does the divide do? Well, the divide doesn't care if they're the same sign. So it throws away half of the information. It throws away if they're a negative divided by a negative is the same as a positive divided by a positive. Right? So once we divide them, that information's gone. And the same is true as it doesn't, if it's a positive divided by a negative, you get the same sign if it's a negative divided by a positive. So when we do the divide here, we've lost the quadrant information. Right? We've lost which information the quadrant is in. So we're cursing at this. You know, expletive deleted.
What did we multiply here?
We multiplied the power signal, the signal we
Oh, right,
input into the
right.
device by
Yes.
each of the sensor signals.
Right,
Right? Okay? So we look at this and we grumble, we curse our instructor, we say, talk about his probable ancestry and relationships to well, yes. So anyway, yeah. So okay, now, so how do we get around this? Well, fortunately, and I will tell you a little secret. Guess what? We're not the first person that's had this problem. This problem's been around a long, long time, right? And the way we get around this, right, is people have not, we don't do the division. Because when we do the division, we lose the sign information. The SIGN information, right? We lose whether it's plus or minus. Because we actually have, if you think about it, we've got all the quadrant information in there, right? If they're both positive, it's first quadrant. If they're both negative, it's third quadrant, right? The slope is still the same, right? The slope is still the same, but it's whether you're in this quadrant or whether you're in this quadrant. And if they're both negative, right, we can tell them apart. It's in the pluses and minuses in the signal. So this division is what's killing us. So if we go to mathematics, elementary, trig, we see arctangent here, which is the one that we're kind of cursing. And if we look down underneath it, there's one that says
Eighteen.
Atan2.
I saw that earlier.
And if you look really closely on the side, what it says is it says Y and X.
Mm, okay.
Okay, and the reason